In this example video, we're going to answer the question, what is the fundamental frequency of a standing wave in a stop tube of carbon dioxide at 0 degrees C that is 2.5 meters long? So anytime we're talking about a fundamental frequency, that tells us that we're dealing with standing waves. And it's a stop tube of carbon dioxide, which means that we're dealing with standing waves in a quote-unquote air column. It's not really air this time, it's carbon dioxide, but some sort of gas. And since it's a stop tube, that tells us that it is one end open rather than two ends open. So I wrote my fundamental frequency equation down, where frequency is equal to the harmonic number, since its fundamental frequency be 1 in this case, times the speed of the wave through the carbon dioxide, divided by 4 times the length of the tube. So we want to know what frequency is. We know n equals 1 because it's the fundamental frequency. And we know what the length of the tube is, the 2.5 meters. So the last thing we need is the speed of sound through carbon dioxide at 0 degrees Celsius. Luckily, there is a table linked in the learning management system that directs you to a list of speed of sounds through various gases. So you can look up the speed of sound through carbon dioxide at 0 degrees C in that table. Otherwise, we'd have to use the formula where we'd have to look up the molar mass and the adiabatic index and everything for carbon dioxide. But luckily, there's a table that is pre-calculated for us available. So once I plug those numbers in, I find that the fundamental frequency is 25.9 hertz.